As Earth approaches, the gravitational differential between the two bodies becomes extreme. Jupiter, over 300 times more massive than Earth, exerts a tidal force that begins to deform Earth even before contact. Upon impact, kinetic energy equivalent to over 10 to the 29th power joules is released, comparable to billions of nuclear detonations. The collision produces temperatures exceeding tens of thousands of degrees Celsius, enough to vaporize silicates and metals instantly. The massive shockwave propagates through Jupiter's dense hydrogen-helium envelope, compressing gas into high-energy plasma. Much of this material is ejected into space at escape velocity, forming temporary gas plumes extending hundreds of thousands of kilometers from the impact site. Earth's core and mantle are quickly stripped apart and begin to mix with Jupiter's partially metallic hydrogen layer. The debris is not dispersed into a ring system as might occur in lower energy impacts. Instead, gravity pulls most of the material back inward. As the system stabilizes, the result is not two planets, nor a planetary remnant, but a hybrid gas mantle object. The core is a molten high-density fusion of rocky material, encapsulated in a still-heated layer of compressed gas. The new object is temporarily brighter in infrared, emitting residual heat from the collision, and may show magnetic field instability for some time due to internal restructuring.